Hi, I'm Farhana and welcome to another lesson on trigonometry rules. Today we'll be focusing on proofs and applications of the three rules. Let's begin. Okay, so I'm sure you've always wondered, how is it that we know that the sine rule, the cos rule and the area rule are actually giving us the correct answers? So, how we know that these rules work is we first learn to prove the rules. Because we have a proof that the rules actually work for any triangle, then we know universally that these rules can be applied to any triangle. Let's begin with the first proof. We're going to start off with the proof of the area rule. Let's begin. So, look at our concept map. We've done all three rules already, and today we're focusing on the proofs and applications. Can you remember what the area rule was for any triangle ABC? So we had three versions. The first version was area equals half AB times sine of the angle C. Second one, half BC times sine of the angle A. And the third one, half AC sine of the angle B. And can you remember what order we needed the angles and the sides in? Or in other words, what pattern were we looking for? We were looking for side, angle, side. So basically, again, just to remind you, if we were using that one, we needed A, B, and C. So we're using that V pattern. Okay, so to begin the proof of the area rule, we have to construct H, which is the altitude of the triangle ABC. And specifically, we're going to draw this altitude from the vertex C. So what that means is we go to the drawing and we begin at C and we draw a perpendicular line from C down to our base. And can you remember? This should look quite familiar to you. We've done this lots of times. So that's going to be your height of your triangle, and this would now be the base of your triangle. Okay, and this little c would be the base. So, if you can remember from grade 8 and 9 geometry, how do we find the area of triangle ABC? Okay, so triangle ABC, it's half base times height. And what is our base in this case? Our base in this case is this line here, AB, or in other words, it's little c. Okay, and our height is the height we've constructed, which is this height. So, CH. So, if we were to find the area of triangle ABC, it will be half C times H. Now, looking at this triangle AC, and I'm going to label this piece here D. Looking at triangle ACD, we're going to try and find the sine of angle A. And what is sine of angle A? Sine of A is opposite over hypotenuse. So, let's write that down. Okay, so sine of A is opposite, and the opposite side to sine A was H. And the hypotenuse in this case was the hypotenuse for this triangle. So it was B. Okay, and rearranging this, we multiply both sides by B, so we end up with H is equal to B times sine of alpha. Okay, this is standard grade 10 trigonometry. Okay, now we're going to take this value for H and we're going to substitute it into this formula that we have written originally. So let's do that quickly. So we're going to have half C. Now instead of putting this H in, we're going to put in what we found for H here, which is B sine A. So it's going to be B sine A. And can you remember what we were trying to prove? We were trying to prove that the area of the triangle ABC is equal to half AB sine C. And if you look at what we have now, if we just rearrange this, it's going to be half BC, just to put it in alphabetical order, and something that looks familiar, half BC sine A. So, we've proved one case of the area rule, half AB the area of triangle ABC is half BC sine A. Okay, and similarly, we can prove the other parts of the sine rule. And can you remember what the other versions of the sine rule are? Of the area rule. So the other two that we can prove that it can be half AC sine B, and that can be the other area. And if we draw the height in a different place, we can then prove the third version, which says half AB, and we're using sine C here. Okay, so this area rule we did now, and the proof we did, was one particular proof using the height from the vertex C. If we moved around the height, then we can get the other two formulas that we've just shown you now. But if you notice carefully, the example that we've used now is an acute angle triangle. What happens if the triangle is obtuse? Let's quickly go through the proof. It doesn't change much except for one small tiny bit. Let's go through that quickly. Okay, so if the triangle was obtuse, then we draw the height as we usually would for the triangle there. And this would have been our angle A, so the adjacent angle would be 180 minus A. And how does our proof change for that? If you go through the steps for our proof, nothing changes much. Our area of our triangle ABC is still half the base times this height here. So half C times H. And now the one thing that does change a little bit is if we look at sine, we're looking at triangle ACD again as we did in the previous proof, but now in triangle ACD, our sine of this angle, we're going to be using this angle. So sine of 180 degrees minus A will equal to opposite over hypotenuse, so H over B. So sine of 180 minus A in our triangle ACD is equal to, it's equal to sine of 180 minus A is equal to opposite, and our opposite was H, and our hypotenuse in this triangle was B. And then we have to remember that because sine of 180 minus A from our trig rules, because this is second quadrant, is just equal to sine of A. So nothing changes from here onwards because now sine of 180 minus A, I can replace this with the sine of A, and we retain this H of B on this side. So what does it mean? It means that sine of A is equal to H over B. And when we rearrange this again, we end up with the same version of H that we had earlier, which is B times sine of A. And again, we're going to substitute that for this H that we had in our original formula for area. So again, exactly like we did earlier, H equals to B sine A. So we're going to put into here, we're going to put this for H, for this H that we had in this formula here, we're now going to put it in here. And so we end up with area of triangle ABC is equal to half CB sine A. And if we rearrange it in alphabetical order, it's just half B C sine of A. So you can see that the proof of the obtuse angle triangle is not much different. We just got to consider our angle being in the second quadrant or 180 minus our original angle. Okay, we have to go for a short break. I'll see you after the break.